Hi, all. Welcome to the session of our Biostats Made Simple webinar series under the Research Learning series. My name is Christine Ramdin. I am a faculty member on the research track at Rutgers, New Jersey Medical School, Department of Emergency Medicine. Okay, so in the case where you have two groups, two variables that are essentially proportions because they are from an originally nominal variable, such as like gender. You can have like a proportion of females or a proportion of males, or if you're looking at two groups, two populations of people, and you want to know the proportion of males in one group and the proportion of males in another group, then, what test you compute the proportion, but then what test do you use to compare the quantity of males in both groups and analyze that for statistical significance? So when you have any situation where you have a nominal variable, and this could be color, if you had colored marbles and you have bag one and bag two, and you want to know what the proportion of variables that are yellow in bag one and the proportion of variables that are yellow in bag two, and you want to compare whether there's a significantly greater proportion of variables and yellow variables in bag two compared to bag one, then you would use something called the chi-squared difference of proportion test. And if that does not work, you use something called the Fisher's exact test. And why I say that, there are criteria for using the chi-square test. And usually if it doesn't work, it's because your either numerator or denominator is very small. And I know you can do, and many people do, the chi-square difference of proportions test or Fisher's exact test in SPSS, and it's very easy. It's under the crosstab command. When I go to SPSS, I can quickly show you guys where you can find that. But I did this in the second webinar or third webinar, and I still use this till this day. There's an online calculator called Biostats. It's been validated. You can, in general, my comments, and I've said this before on online calculators, if it has references regarding the statistical test and how it's used, if it has notices that says the output from this calculator has been verified from SPSS, SASS, or some valid statistical software, usually those are good to trust. However, as I said, I really only use like Vassar stats if I'm doing like a really simple chi-squared difference of proportions test for like an abstract or something. Otherwise, I highly suggest you use like a statistical software such as SPSS. The reason why I liked using Vassar stats for the chi-squared difference of proportions test is because if it fails, it gives you an error. And I don't think I have that here. Oh, I do have it here. So if like your samples, if your proportion are too small or your numbers are too small, like 5 out of 12 and 3 out of 10, if it fails the criteria for the chi-square difference of proportions test, it gives you an error that says that it does not meet the criteria for the chi-square test. And that's why you have to use the Fisher's exact test. So that's why I like you doing that. But just to put this back in context, if we had bag one with 35 marbles in total and bag two with 30 marbles in total, and then in the first bag, 20 of those marbles were yellow, and in the second bag, 10 of those marbles were yellow, and we wanted to know if there was a significant difference in the proportion of yellow marbles between bags, we would use the chi-squared test first, and if that fails, it's Fisher's exact test. When we do this and we calculate, as we see, we have both our one-tailed and two-tailed p-values. Just a quick reminder, your two-tailed p-value is literally double your one-tailed p-value, and why you would use one over the other. So two-tailed you would use to evaluate whether there's a difference, any difference at all, and one-tailed p-value report when you're trying to determine if something is significantly greater than the other. You're trying to determine direction. So my original question was, are there significantly more yellow marbles in bag A compared to bag B? I would obviously look at the one-tailed t-test because I want to know if it's greater. Because we see that the proportion of yellow marbles there is 57%, and in sample B, the proportion of yellow marbles is 33%. So for the one-tailed p-value, the p-value is 0.03 approximately, and per our definition, statistical significance that's generally accepted, the cutoff is 0.05. Since p is less than 0.05, there is a statistically significant difference. The proportion of yellow marbles in bag A is significantly greater than the proportion of yellow marbles in bag B. So then if our sample sizes were much smaller and we failed the chi-square difference of proportions test, we would go to the Fisher's exact test. And I explain how to set up this table more in that second or third webinar. But it's just important for you guys to know that when that test fails, you use that test instead. and you get your p-value, which is 0.67. This output is from another one of my favorite online calculators that's been validated, Social Statistics. It's really quick and easy when you want to do like a quick calculation for an abstract, etc. And you don't need to report that you're using SPSS example. Again, not that I would always encourage you to use like SPSS, SAS, etc. But if you're trying to do a quick calculation and you need something quick, then this is definitely one way to do it. The other big thing about this webinar series is I brought up the concept of the Shapiro-Wilks test, or its alternative, which is the Kolmogorov-Smirnov test. And why this is so powerful, oftentimes in the literature, that when people are doing comparisons between groups of data, continuous and scalar data, especially when we're doing things like looking at test scores and we want to see if there's a significant difference pre and post. And sometimes you have identifiers and sometimes you don't, which identifies whether you use, like, for example, a pair t-test or not. A lot of times in literature, there's like these fancy tests reported, right? Like we see that people use the Mann-Whitney U test or the Wilcoxon-Sine-Square test. And then you look at it as a junior researcher like that probably hasn't taken a stats class forever and think to yourself, well, I know when you compare two groups of scores, you use like the t-test or the pair t-test. Why are they using these other tests? And the answer is that these test scores do not meet the criteria for data normality. And I'm sure many of you that have published have had reviewers come back to you and tell you that, have you checked this data for normality? Or are you sure that the t-test is appropriate to use here? And this is how you answer them. The answer is that, yes, I checked for data normality and I use the Shapiro-Wilks test. Generally, you use the Shapiro-Wilks test, and this is also cited in literature. I believe it's like when you have a sample size of like 2,000 data points or less. And and we've said this previously, sometimes we wish that there's like a science for this. Sometimes there's not, but as long as you like refer to the literature, there's mathematical literature, there's like literature for stats in medicine that says that this is the accepted cutoff and what it should be, and you cite that, then generally you won't get questioned for it and the reviewer will take that. But generally, so what I've seen, if your data set is like 2,000 data points or less, you use the Shapiro-Wilks normality test. This could be easily done in SPSS, and for previous attendees that haven't attended, I'll show you guys quickly how to get to that, but I've previously done it in many previous webinars, so you guys can just quickly review those. It's a really quick calculation. So the way you do this, you input both of your data sets, your pre and post, for example, or group 1 and group 2, into SPSS, and you check both of them for normality using the Shapiro-Wilks test. And that's why you see on the left hand of my screen, I have it variable 8, 9, and 10 here. These are 3 different variables, and I tested them for data normality, all 3 at the same time. And here, I noticed that the p-value, that's our significance here for the Shapiro-Wilks test, is greater than 0.05. And when it's greater than 0.05, that means your data set is normal. In order to use any normal statistical test, which I'll present to you in the future slide, I'm not sure if that's the next slide, you can use the parametric or normally distributed tests, such as the peer t-test, the student's t-test, the ANOVA test, etc. However, if even one of these, if you're comparing 2 of these variables, and even one of them comes back normal, that is p is less than 0.05, not normal, that's p is less than 0.05, then you have to use the non-parametric alternative to that test. And I'll show you what those non-parametric alternatives are in the next slide. And as I've shown in all the previous webinars, they're very easy to do in SPSS. You just have to be able to identify whether your data sets are normal or not, and then select the appropriate test. And then Kolmogorov-Smirnov works the same way. This is generally if you have 2,000 plus data points, then you would use the Kolmogorov-Smirnov test for normality. So this is essentially a review of at least maybe 5 to 6 of the webinars I did, where I actually went through examples of each of these tests and when to use them and how to do them in SPSS for scalar or continuous variables, because like, for example, test scores are scalar and continuous variables, heights, weights, etc. Those are scalar and continuous variables. So when you want to do comparisons with 2 or 3 plus groups, these are the tests you would use for your parametric and non-parametric cases. And again, parametric or non-parametric is dependent on that result of that Shapiro-Wilks or Kolmogorov-Smirnov's test. So that Shapiro-Wilks test was kind of like the big breakthrough for deciding what kind of test to use outside of figuring out what test to use based on the type of variable. So when reporting papers, I'm sure you guys have often seen when the authors are doing descriptive statistics, sometimes they report means and sometimes they report medians. And the reason for that is, again, it comes back to this concept of parametric versus non-parametric data. So you report means and standard deviations when your data set is normally distributed, or you pass the Shapiro-Wilks test, that is p is greater than 0.05, and you report medians and the associated interquartile range if at least one of your data sets fails the Shapiro-Wilks test. That means p is less than 0.05. So the Shapiro-Wilks test is your friend. You'll carry it throughout, or the Kolmogorov-Smirnov as appropriate. So definitely use it to your advantage. And that is something you always want to report in your method section of your manuscript or your abstract. So you avoid getting questioned by reviewers, or you prevent an unnecessary comment, or it's just a stronger way to justify your methods as explaining what you did. When you have a data set, when you have two data sets, like pre or post, and like, for example, they're not identified, you don't have student identifiers, so you can't link between sets, or you have two groups of weights or something, and you want to compare the weights between groups or heights or whatever, you can use either the independent samples t-test if your data is normally distributed, that's both data sets must be normally distributed, or you use the Mann-Whitney U-test if at least one of them are not normally distributed per the Shapiro-Wilks test. And the same way, use the pair t-test if you have two sets of test scores, say, and you can link them, meaning you have a student, you can link student one in pre-test to student one post-test, and you're able to link this throughout your data set. You can use the pair t-test if your data is normally distributed, both data sets per the Shapiro-Wilks test. Again, p has to be greater than 0.05 for both. And if it fails that, for at least one of the data sets, you use the Wilcoxon-Sign rank test. Again, if you're in the unique case where you don't have like two test set scores, but you have 3+ test set scores, if you're comparing between three groups of students and whatnot, you use the one-way ANOVA test. If all three of those groups are normally distributed, again, per the Shapiro-Wilks test, if at least one of them are not normally distributed, then you use the Kruskal-Wallis test. For repeated measures is the unique case. You kind of think of the correlate as the pair t-test when you have data links between three groups, like if you're looking at plant heights over time at different times, or student test scores at point A, point B, and point C, and you can link all the students. Then if all three of those data sets are normally distributed, you use the repeated measures ANOVA test. If they're not normally distributed, you use the Friedman test. And what I'm going to do is, for a quick second, I'm going to stop sharing and I'm going to share SPSS really quick so we can quickly go through where these commands are. And again, for more details, you probably should look at the previous webinars. So let's go to SPSS. Do not get intimidated. This is the NHAMCS data set open, which I'll discuss later. But I just want to, especially for those that haven't been here before, quickly familiarize you with SPSS and where to find things, right? So here's our data view. It looks like Excel. And I've said this over and over again, and I'm going to say it again, that SPSS looks like Excel, but it does not function like Excel. So like in Excel, you can easily type words and stuff. You can easily type words here too. But when it comes down to analysis, SPSS is completely non-tolerant and will not take that. SPSS likes a clean data set with coded data. As you can see, like gender, for example, here is represented by 1s and 2s and not male and female. So for analysis purposes, you just want to make sure that you code everything appropriately and put it here. This is your data view. And then if you want to label your columns, for example, it takes you to something called your variable view, which you just can click on the bottom. Each row of the variable view corresponds to the corresponding column in the data view. So row 1 here, which is month in the variable view, corresponds to column 1 here in the data view. I'm going back to the variable view for a second because this is very important. So when you're in the case where you have, for example, like a nominal variable, right? That's a variable that is a categorical variable and it takes on more than one category. Then you want to make sure that number 1, clearly it's not labeled here, but whenever you're doing your own research or utilizing a data set, it may make sense if you just want to go through and label the variables accordingly if they're scalar, ordinal, and nominal, because it's helpful to you to stay organized and track, determine if you have to put in any categories, and also help you decide what statistical test to use. So I'm going to go to here quickly, patient gender. I'm going to click on the measure because I know it's a nominal variable, so I'm going to code it as nominal. And then values. So if you were trying to put in your data set from scratch, obviously it's not going to be here automatically labeled number 1 for female and number 2 for male. What your job is to go and literally inputs, like you can add another category here and say like 3 transgender female or something of that nature, or transgender male, etc. So you use the value labels in order to label your variables so you're able to keep track and know what each of your coded variables are in the data view. So that's very important to keep track of things. Now we're already at 2:22 and I know we're constrained for time. So I'm just going to quickly show you guys most of the analysis commands you're going to do in SPSS are obviously going to be under the analyze button. So usually if we're doing like simple comparisons between 2 or 3 groups, and if the data set is non-parametric, that means they fail the Shapiro-Wilks test. Obviously, you probably would go to the non-parametric dialog tab and then click on legacy dialogues. And I apologize for saying obviously for new attendees. I say it obviously for those that have already attended because we've done this so many times and people are probably tired of hearing me say it again. Usually SPSS speaks in the language we speak, right? So if something is non-parametric, it makes sense to look under the non-parametric menu. And if you go to legacy dialogues, and the labels will kind of figure out where you have to go. So I discussed the example where you have 2 independent samples, right? That's when you have like 2 sets of test scores, but they're not identified. You just want to see if there's a difference in between means. So obviously you have 2 independent samples and you probably click 2 independent samples. And then the Mann-Whitney U-test is the one you would use for 2 independent samples that are not linked, right? So just by reading the names kind of helps you get the sense of what to do. Then legacy dialogues, if you have K-related samples or K-independent samples, what does the K mean? It simply means that you have more than 2. It could be 3, 4, plus, etc. That's why it has K. So obviously for independent samples, you would look at the Kruskal-Wallis test for non-parametric data, if at least one of your data sets is non-parametric. And for related samples, that's for when you have 3+ data sets that are linked in some way, then you would use the Friedman test, which is the non-parametric correlate to the repeated measures ANOVA test. So that's what you would do for non-parametric tests. Usually for parametric tests, that's for when both of your data sets are normal. We have the pair t-test, the independent samples t-test, etc. under the compare means and proportions menu. So a lot of this is just really intuitive. You just have to know. And also, I just want to bring up again, how do you do the Shapiro-Wilks test? So if you want descriptives and frequencies of your data, like they're literally right here under the descriptive statistics menu. But in order to do the Shapiro-Wilks test, again, this is for scalar and continuous variables, you would hit explore, and then the appropriate scalar or continuous variable. And again, this is what the power is, how important it is to label all your variables appropriately, because as we see in this data set that I exported from the CDC website, everything is labeled as scalar, and we know that's not true, but this could be very misleading, right? Because if you're trying to do the Shapiro-Wilks test, you want to make sure that scalar variables are measured scalar so you don't make a mistake. So length and visit, we know length is definitely a scalar variable, so we can move that here. We can click plots and click normality plots of tests and click continue, and that'll give you your Shapiro-Wilks test result. So that's for that. And with that, I'm going to stop sharing and go back to my slides. And then just to quickly recap on our different type of regression analyses. So the way I chose to explain this, because I figured it'd be easy to remember and having a breakdown will make things easier to understand, I separated what I thought, based on what I've seen, some of the most common types of regression analysis there are in our extant literature, from which you guys can take and build off more complicated models of that. I kind of split this into 3 categories. So dependent variables being either continuous or scalar, nominal or ordinal, and there's also regression analyses for count data. And what I mean by count data is essentially like your number of occurrences, number of events, number of deaths, number of adverse events. So that when people use the Poisson regression, that's what they're doing. They're modeling the number of events, they're modeling the number of deaths, etc., and they're trying to determine what are the best predictors of that. So that's why people use the Poisson regression. For continuous and scalar variables, we have dependent variables. We have 3 types of regressions we use in general. We have our basic linear regression, which is a special case where you have exactly one independent variable that you're trying to associate or correlate with one dependent scalar or continuous variables. And you use the Pearson's correlation coefficient for the linear regression as appropriate if both your dependents and independent variables are normally distributed as determined by the Shapiro-Wilks test. You use the Spearman's rho coefficient after running the analysis to determine if at least one of the variables comes back as not normal. You would use that analysis to associate your dependent variable. And the difference between those 2 analyses is simply that the Pearson's correlation tells you if there's a strong or weak linear association. Again, this depends on the parametricity, if that's a word, whether both data sets are normally distributed. And Spearman's rho essentially tells you if there is an increasing or decreasing, not linear, association between your independent variables. The multivariable regression is these terms are used alternately in literature, used in the special case when you have exactly one scalar or continuous dependent variable, but multiple independent predictor variables that can take on any form. They could be nominal, such as gender, race, etc., scalar or continuous, such as age, weight, height, or they could be ordinal, such as your Likert scale type variables. And you want to see the association with those independent predictors to that dependent variable. Your general linearized model is a special case when you have two dependent variables, again, scalar or continuous dependent variables, and you're trying to correlate those with multiple independent variables. So it essentially is trying to determine whether there's an association between those independent variables and either one of those dependent variables. So it'll give you regression output for both of those dependent variables. For nominal dependent variables, you would either use the binomial logistic regression or the multinomial logistic regression. Binomial logistic regression means your dependent variable takes on exactly two values, meaning it could be true, your dependent variable could be in the form of true, false responses, yes, no responses, so on and so forth. Multinomial logistic regression, obviously, the dependent variable takes on multiple categories. So it could be something like color, car type, etc., because there's more than two categories, right? So color, we can have various colors that we want to determine what predicts someone's favorite color. We can have blue, red, yellow, etc. And what the output will do is kind of give you output for each of those variables, show you what the predictors are for each of those dependent variables. And this, let's see, ordinal dependent variables, there's an ordinal regression. So again, it's in the name. And then the output looks similar for each of these types of variables as discussed in the previous webinar. It's just becoming comfortable with it and understanding how to interpret your results. And then lastly, for count data, you use the Poisson regression or negative binomial distribution as appropriate. Poisson regression you use when, your Pearson chi-squared, whichever model produces a Pearson chi-squared closer to 1 and has AIC and BIC that is less is the better model. So you would have to run both models and see the model fit. And that comment goes for the rest of the models. You have to make sure your model fit is good. And for different types of regression analyses, there are different model fits. So you want to make sure you go through those results, which I've explained in the previous video. The Nagelkirche R-squared tells you how much of what percent of variance in your dependent variable is explained by your input variable. So that's like one measure of model fit. And then there are specific tests such as the Hosmer-Lesmo test, a Pearson chi-square test for different models. So I highly suggest you review those. Those are important to report in your papers as well, because there's no point in reporting a model with adjusted odds ratios, etc., if it wasn't that good. Okay, this is an example of what output looks like, right? So it looks like here, beta is used when we do like a multivariate regression analysis. So let's take an example. That'll be easier to explain. So if we're looking at age, we say a beta here is 0.035. So if our outputs variable was, say, height or something like that, the way we interpret that is that for every 1 unit increase in age, the height would increase by 0.035. So that's how you interpret beta here. And then clearly, since we have an exponent beta here, which is, as I say, is the adjusted odds ratio, since there's an exponent beta here, this is not a linear regression. This is probably the outputs of a multinomial logistic regression or a binomial logistic regression. Your exponent beta is your adjusted odds ratio. So when you're conducting those type of ratio, you don't look at your regular beta, you look at your exponent beta. So here, first you evaluate for statistical significance. We see here that we have car type in category 3 as 0.019, which this in normal circumstances would be ignored because overall car type wasn't significant. But for example purposes, since our p-value here is less than 0.05, this is a statistically significant result with an odds ratio of 15.9. So those are the results that you take into consideration. And pretty much this is how you interpret the output for most of the regression analyses, with the exception of the linear regression where you focus on the beta, not the adjusted odds ratio. So those again are explained in the previous videos, and I highly encourage you to look at that. Okay, so this is our big summary overall for all those previous 8 videos. So again, the type of statistical analysis you use, the type of regression analysis you use in the summary is based on the number and type of the dependent variable that you have. And again, number comes into play when you have like the GLM, the general linearized model, where you have 2 independent variables that are scalar continuous. But that's in general, the type of the dependent variables could be nominal, scalar, or ordinal. So that's a good way to think about it, to narrow down what kind of tests you should use. And again, Poisson regression is a special case when you have count data, right? And then we went through all of this already. And just remember that your exponent beta is your adjusted odds ratio. And you should report that with your p-values and the confidence intervals for your adjusted odd ratio in your papers. Okay, so now we're just going to go on to databases that are commonly used in ED research, to my knowledge at least. So we have NHAMCS database, which is publicly available and free by the CDC. That's the abbreviation for the National Hospital Ambulatory Medical Care Survey. There's also a NHAMCS without the H. It's NHAMCS. That's for outpatient databases. Since this is a Society of Academic Emergency Medicine, obviously it makes sense to talk about the one that pertains to the ED. Then we have the HCUP databases, which I'm sure you guys have heard about as well, but those you generally have to pay for. So usually if you get grant funding or your department pays for it, etc., those are not freely accessible, but they could be purchased on the HCUP website. There's 2 of them. There's the NEDS, the National ED Database, and there's the state databases. And the difference between HCUP and NHAMCS is that HCUP comes from billing data. And NHAMCS literally comes from chart extraction. So what the CDC does, it has representative samples of sites across the United States. And these representatives are trained and they manually abstract data from charts, EHR charts and whatnot for patient visits. And then this data is input into a database for further analysis, weighting, etc. There's the All of Us database. And there's the treatment episode database, TEDS database, which could be found on the SAMHSA website. And also just to point that as an ED, we do a lot of addiction work as well. And a lot of my research focuses on substance use disorders. That's why I know this so well. A lot of these databases are freely accessible under SAMHSA. So that's just a resource for other people. All these databases are available in SPSS format. And that's what I was saying. So SPSS, they also have other formats for those that are more familiar with the programming languages like SAS and R. They're available in those formats as well. Just to let you guys know, if you ever come into a situation where like something's only available in R or SAS and you're not comfortable using that format, there are very simple commands in R and SAS to convert that database to SPSS formats and vice versa. So the NHAMCS database, just a quick overview about that. It's a representative sample of ED visits. Currently, they have data up till 2022. Visits are weighted to provide national estimates. So meaning that obviously the database does not contain data from every single ED in the United States. It takes a representative sample, and then the CDC, a statistical analysis, what they do is they use that sample and they use statistical methods to come up with weights for these visits to say that, hey, if we abstracted data from all the EDs in the United States, we anticipate that this particular visit would be representative of 20,000 visits, say. So usually when conducting these analysis, it's heavily suggested that these weights are used. Otherwise, you are definitely most welcome not to use the weights and say that you're not sure what the method is for coming up with these assumptions for the weighting analysis. You're more than welcome to do that, but you would have to justify that in your paper. It contains data on patient demographics, visit characteristics such as imaging, labs, meds, etc., and as well as characteristics for hospitals. One thing to note about the NHAMCS database, it's good for providing estimates for conditions that are highly prevalent. Otherwise, these other smaller estimates should be taken with caution. All right, so I just showed you guys a little bit what the NHAMCS database looked like. I'm going to quickly look at the variables and we're going to do a quick example. So let me stop sharing and we're going to share the NHAMCS database. So again, this is what the NHAMCS database looks like. As I told you guys before, all the data is in here. In terms of variables, like everything is poorly, like the measures are not indicated, etc. So if you're a junior researcher and you're just trying to acquaint yourself, for your variables of interest, you should probably go down and label things as appropriate. Like length of visit is clearly a scalar variable. Age, they have it both in categorical formats. Well, I thought they had a numerical format, but they have it in categorical format, right? So they have it coded like 1 represents under 15 years, 2 represents 15 to 24, etc. So clearly this is a nominal variable. So we're going to click nominal here and so on and so forth. So these are the variables here. The label for the variables tell you what that variable is, right? So we have gender, we have race, we have expected source of payments. There's one, and this is the one I love using, there's one variable that just summarizes all the types of payments. So if the patient has private insurance, it'll indicate that as one. If they have Medicare, two, versus just using the different variables that are here. So just becoming comfortable with the database is important for you to kind of like set up how you want it as your own. Other things I want to bring your attention to. So we have diagnosis codes. Obviously, prior to 2016, we were using ICD-9 diagnosis codes and not ICD-10. So when you're using diagnosis codes for an analysis, if you want to look at a particular condition of interest, just be very careful, because unless you have a good way of correlating your ICD-9 and ICD-10 codes, if you want to look at an ICD-10 code, you probably should do your analyses using the 2016 database onwards, because they're labeled in ICD-10 format. So there's like your diagnosis codes. There were allowed up to 5 diagnosis codes to query here. And I'll show you guys how to do a quick query in the example, but it's going to be for meds, not diagnosis codes. But essentially the same concept for querying applies throughout. So we have diagnosis codes here through which you can query. There's like basic general comorbidity things you can look at. So if you pull up patients that, I don't know, maybe have an intracerebral hemorrhage, ICH, and you're just specifically looking at that data set, and then you want to know how many of these patients have hypertension, et cetera, then you would just look at the frequencies for hypertension in that query data set. And I'll show you what that kind of looks like a little bit later. So there's like obesity, hypertension, et cetera, common comorbidities, then the type of labs the patient may have had done. So if you're looking at a particular diagnosis, if you're interested in the particular lab work the patients may have done, visits, like you can easily query it here. And I'll show you guys how to quickly do that. And then we have up to 30 meds, right? So we all know that patients are given various meds in the EDs. And so the NHAMCS database provides us with data for up to 30 meds. And if you're looking for utilization of any particular med, right? Say if you want to look at the prevalence of use of hydrocodone at either discharge or at administered during the 30 visits, the correct way to do it is query all 30 medications, right? Because it could be given in any order. It could be given the first medication given, the second medication, etc. And then we see this variable here called GP med. And essentially what that tells you is whether that particular medication of interest was given in the ED, like administered during the ED visit, if a prescription was given at the ED discharge, or that prescription was given both during the ED visit and at discharge. So if we were interested in conducting analysis with discharge medications, which we'll do very shortly, we probably want to make sure that we have both 2 and 3 checked off, right? So just to give you an idea, so GP Med 1 here corresponds to Med 1. So that means if our Med 1 is hydrocodone, then we're going to look at GP Med 1, the output for that, to determine whether that was given, that particular med was given in the ED, was given at discharge, or both at ED and discharge. So it's important to correlate the appropriate med with the appropriate GP med to get the analysis exactly what you're looking for. And this is going to be very much more clear in the example, which I'll give you in like a second. And these are like provider characteristics about the different providers seen in, that may have seen the patient in the ED. And this is for like a more sophisticated analysis, which I won't get into here, but like if you have drugs classified under a particular category versus looking for an individual drug, this is how you would do it. And these are coded up to 30. So that's what takes up most of the rest of the database. And then we have our patient weights, which are very important. That's the visit weight as approximated by the CDC, etc. So with that being said, I'm just going to stop sharing and I'm going to just give you guys a quick example. So 1 or 2 years ago, I was just really fascinated by the fact that, I was thinking in my head, being a PhD and all, the opioid epidemic was caused, it was initiated by prescribing of prescription opioids. What if the prescribing of amphetamines was associated with increase in methamphetamine use? And as we know, there have been some articles published that show no association, but regardless, me and my mentor, who's Dr. Marianne Amershahi from Georgetown University, was very interested in looking at prevalence of amphetamine prescriptions at discharge from the ED, because generally there's not a lot of indication for that. So I'm just going to use that as an example. So the first thing you do is figure out what codes the NHAMCS database uses to identify these meds. And I'm just going to quickly show you the website through which you can kind of look this up. So I'm going to go here. All right, so the NHAMCS, and you can just really Google this, it'll come up. It has a drug database through which the drugs you want to look up, the medications you want to look up, can be identified by a particular code. So obviously we don't know the codes by the top of our head because there's so many codes and this is CDC specific. So if I want to look up amphetamines, for example, right? So I can type in amphetamine, I can type in Adderall, which is a type of amphetamine. If you type in all the names, it'll have specific codes for those names. So I'm going to type in Adderall, click Adderall right here, and I'm going to click search database. And this link is available in the slide, just so you guys have access to it. And we see here that the NHAMCS recognizes Adderall or amphetamine, dextroamphetamine as two different codes, as 0.1281 and 95016. So in order to do an appropriate analysis, you have to ensure that you're taking into consideration both of these codes when you're querying the database. Now, let me show you quickly how to query the database. And again, all this is going to be in the slides. So although it feels like we're rushing through it, like it won't feel like that once you look at the slides and you do some of this yourself. I'm going to share my slides. So here I show you that the NHAMCS has Adderall coded as these two different codes. So in order to obviously abstract visits that have amphetamines prescribed, we have to query the database for these specific codes, right? So recall in GP Med, if we want to look at discharge prescriptions, 1 is for administration in ED only, and 2 or 3 take into consideration discharge prescriptions. So we want to make sure our query takes into consideration only the cases 2 and 3. That is when the code 95016, amphetamines, comes up as a 2 or a 3 in GP Med. So, and we also need to take into consideration the fact that any of those meds, like amphetamine could be Med 1 or it could be Med 30, because the database encompasses up to 30 meds. So this is what, and for programmers, it's easy to understand this, but for those that don't have a programming background, I'm just going to quickly explain to you what this means. It's all repetition. So Med 1 is equal to 95016. What that essentially means, I'm telling the database that the variable medication 1 in the database, I want it to look for 95016, right? And that's the code for amphetamines. And these quotation marks are telling the database to essentially look for that because in the database it's labeled as a string variable. So it's not labeled like equals 1 equals 2. So that's why it considers 95016 those codes as strings. So that's why I have to put those in parentheses. And obviously this might be hard to remember, but whatever you're doing on medication analysis, feel free to copy and paste and modify this code as you need to. And then so I'm telling it to look for 95016 in the category for Med 1, but I also want it to look for 95016 when GP Med is equal to 2. That's in the specific case where the discharge prescription is provided in the ED. I don't care about 1. Remember, I'm just focusing on discharge on prescriptions and so on and so forth. So I keep on repeating that. So I want the database to look to see whether Med 2 also has 95016 and GP Med 2 is a discharge instruction. So I do that all the way to Med 30 because we know there's 30 meds right here. And then I start again, and that each of my statements are separated by the term or. And the reason that is because we're saying that we don't want necessarily GP Med 1 and Med 2 to equal 95016 because that's not true, right? Because it's unlikely that a patient is given amphetamine as their first medication and amphetamine as second medication. That second medication could be something else, like it could be an opioid or something. So we're saying that the medication can be in either 1, 2, 3, 4. It could be any number up to 30. And we want to make sure that it's in that specific case where GP Med equals 2. The code continues to have cases where GP Med is equal to 3. And why is that? This is the case, if you remember correctly what I showed you, where the medication is administered both in the ED and prescribed at discharge. So in order for a complete analysis, we have to make sure all cases are captured, right? Because obviously if the med wasn't also administered in the ED, it wouldn't fall under 2. So we want to make sure that we're capturing all discharge instructions. So I'm saying that I want this particular medication for any of these 30 fields, and GP Med has to be 2 or 3. And you literally copy and paste this into SPSS. And let me stop sharing for a second so I can copy and paste it. 1 second. I'm going to copy this. And then we're going to share screen and paste in SPSS. All right, so the way to query the database using this code is going to be, we're going to click on data. We're going to click on select cases. We're going to click on if condition is satisfied, because remember, we're querying based on a specific condition, whether this medication is located in any of these fields. So I'm going to click if, I'm going to copy and paste the code here. And then I'm going to click continue. And then I'm going to click here, copy the selected cases into a new data set so it doesn't ruin my current data set. So I'm going to name it Adderall, because as we know, there's different types of amphetamines. There's amphetamines that are just not Adderall, but I just use specific Adderall for an example here. If we're doing an amphetamine analysis, we have to take into consideration all the amphetamines, which I do more in the paper, but here we're just doing an example specifically for Adderall. So I'm going to hit OK. And then SPSS is running that query to produce all my cases where Adderall was provided as a discharge prescription. So I'm going to click on here. This is the data set that it produced. So from here, out of those 12,000 visits or whatever, it told me that 3 out of those 12,000 visits or whatever have indication that Adderall was prescribed. And these are the visits where. And again, I think of each row as a visit, not a patient, right? Because visit 1 and visit 2 could be the same patient, but we don't know that. So we have to consider them visits. And then, so this is the query for all the visits where patients were prescribed Adderall at discharge. And this is that specific subset. I want to bring your attention to the very end where we have patient weights. Because remember, as I told you, these visits are weighted. So they may have, the abstractors may have gotten this specific visit and visit characteristics from one ED. However, the CDC, using their statistical methods and whatever assumptions they make, they approximated that this visit is representative of 4,065 visits across the United States, right? So in order to know, for example, the total number of visits where Adderall was prescribed, we would just sum these, right, as a national estimate. So we would add 4,065 plus 4,065 plus 12,669. And that will give us the total number of visits for 2022 where Adderall was prescribed. Take into consideration that one code. Just want to remind you guys, there was another code that we did not do. And these are the visit characteristics for this code. Now, I just want to bring you guys back, and I keep on saying this in every single webinar, that how Excel is as important as SPSS in this whole process. Because what you do next, and it's easier to manipulate, like for those who know how to code, can easily code in SPSS and kind of like figure out, okay, how many of these visits were male, how many of these were female, etc. But for those that don't know how to code, it may be simpler to just copy and paste those 3 rows of data into Excel and manipulate it accordingly. So let me just show you guys real quick how to do this in Excel. So for that example, what I did is I copied and pasted my visits into Excel, right? And I did not, as you see, I did not copy every single field, every single column, because there were too many columns. I just copied and pasted my columns of interest. So, and recall again that each of these codes represent something. So if I want to know the age of the patients, category 3 means something, category 4 means something. So what I did was in a separate tab, and again, I put 2022 here. If you're looking at multiple years of data, you could run that query for every single year and have separate tabs to represent each year. Like this could be 2012, 2013, etc., so on and so forth. And then what I did here in Excel, I created a legend for myself. You can always obviously go back to SPSS, but it's probably easier this way. So 1 represents under 15, 2 represents 15 to 24, 3 represents 25 to 44, etc. So then putting that back into context, 3 here represents patients for age groups 25 to 44. So we have a 3 here and we have a 3 here. So if we want to like quantify that, right? So we see that there's 4,000 visits for the first category with the patients that are in age category 3 and 12,000 for the second category, which is also patients in the age category 3. So if we want to say that in 2022, how many patients were that were prescribed amphetamines were within the age range 25 to 44, we would sum 4064 or 12 and 12,668. And that's how we would get those number of visits. And you would continue doing that, right? This is how you come up with your demographics table for gender, ethnicity, race, etc. So you just follow your legend for your categories and you do the appropriate summations based on your patient weights, your national representative. And then like if we were doing an analysis that also incorporated the fact that patients were provided amphetamines in the ED setting, I highlighted where the medications appeared here, right? So 95016 represents amphetamines. So it appears in these places, you just correspond Med 1 to your GP Med 1 here. And we see that all three of these were 2, and this one was 3. So if we had also pulled 1s, that's how we'd be able to differentiate which visits where patients were prescribed versus which patients were just given in the ED versus both. So that's how you would do that. And I know we're like close to 3 o'clock, so I'm going to tie up, and I hope this was helpful. But I figure after you guys rewatch the video and stuff, I think it'll become a lot more clear and you play around this with yourself. So the query is very important. And then remember to select based on your condition, whether it's diagnosis codes, etc. I gave the specific exam scenario with meds, but this could be done for any of those variables that you have in the database. Again, this is for setup, importance of Excel, right? And then we talked about patient weight and how important that was to estimate the number of visits per year. And then if you want to do a trend analysis, obviously you have to do the repetition for every single year. And then use your appropriate regression analyses or correlation analyses, such as Pearson's row or Pearson's correlation or Spearman's row, to determine if there's just a linear trend over time. But if you're trying to adjust for things such as you're trying to do a regression analysis, such as age, race, etc., you have to make sure your data is in the appropriate formats and then run the appropriate regression analysis using these variables. If you want to do an analysis where you want to identify if the same during the same visit where was opioids also prescribed in the same visit where an amphetamine was prescribed, obviously you would have to identify your opioid codes using that same CDC website I showed you, and then look at all your meds 1 through 30 if you have it your subset copied and pasted into Excel, and then you can probably create a new variable to indicate 0, an opioid was not prescribed during this visit, or 1, an opioid was prescribed, then copy and paste that into NHAMCS, and then conduct a regression analysis to see what factors were dependent on whether an opioid was prescribed. Words of caution, I want to remind you guys that the data is weighted. So if you do the analysis in such a way and you do not know how to code, you have to make sure you report in your paper that you conducted an unweighted analysis. And the reviewer might come back and say, well, why didn't you do a weighted analysis? And you can probably justify that by saying that we just wanted to look at the representative number of visits across the database without taking into consideration national estimates, because we weren't sure, for example, what CDC assumptions were when creating those national estimates. But otherwise, there's code you can write in SPSS, code you can write in R or SAS that takes into consideration those patient weights when you're doing such regression analysis. All right, so we're directly at 3 o'clock, and I apologize for taking so long, but I know this was also a very important webinar. So in summary, remember, your regression analysis that you use, your type of statistical test you use depends on the type of variable you have, ordinal, scalar, etc., nominal, etc. And also whether your variable is parametric or not for scalar and continuous variables is important to determine when conducting that statistical test. You can determine normality using the Shapiro-Wilks test. Again, there are several publicly available data sets outside the one that I just talked to you about in several formats ready for analysis. And NANCS is a specific database is good for providing national estimates of common diagnosis, meds prescribed, patient demographics, etc. And you always have to make sure you take into consideration patient weights. And if you don't, you should have an explanation why. And a lot of the basic stats could be used to accomplish these analysis. And Excel is really helpful when you're trying to organize your data, etc., and you don't know how to code or you don't have the time and bandwidth to code, etc. Excel can be very helpful. You can run frequencies, etc. in SPSS, but again, remember to take into consideration those national estimates. And again, thank you so much for showing up to my webinar in an age and where we're heading towards large language models such as ChatGPT, etc., to do our analyses. It's very heartening to know that people are showing up to the webinars and they're trying to learn this. So I really appreciate you showing up. And remember, before doing any analysis in ChatGPT, make sure you read the literature on ethical and trustworthy AI and to see what's been published out there to ensure that whatever outputs you're getting are actually valid. You can also validate your outputs using SPSS, etc. So again, thank you all for your time. And someone made a comment about not seeing some slides, and I will definitely double check that and make sure that they are uploaded if they're not in there. So thank you all. I know we're already over time. Are there any questions? Alrighty, thank you so much. And no, to my knowledge, there is not a possible ability to obtain a certificate for obtaining the series, but maybe that's a question for Lynn and Lane later. Thank you so much, Lynn, and thank you all for helping me do this. And we will see you next month for the 10th session. Thank you all. Have a wonderful day.